Hello everyone, welcome to Unit 1, Day 3 here. We're going to be talking more about the function today, and today we're going to talk about something called going backwards, right? How do we go backwards through a function? So to do that, we need to make sure that we understand how to solve equations, which is something you guys probably learned back in 8th grade math. You probably learned how to solve simple equations. So we're going to review some of that equation solving stuff today, and then we're going to understand how to work our way backwards through a function, which means to find the input of a function if we were given the output. Okay, and you'll see what all that means here in just a minute. But let's go ahead and start on solving equations. And so we're talking about that. So what does it mean to solve an equation? It means that we're trying to find a value of x that makes this statement true. So I want to find a value of x that such that if I were to plug it in, I would get a 2 over here on the right hand side. Okay, and an easy way to figure out how to do that is to move things around in the equation. So move things from side to side until we get the x by itself. So watch me do this, right? You might remember back in 8th grade math, maybe they drew a line just to separate the two sides of the equation, and then to move something from one side of the equation to the other, we always had to do an opposite operation, right? So we see this minus 8, so the opposite of subtracting 8 is to add 8. So I'm going to add 8, and whatever I do on one side of the equation, I have to do on the other side of the equation. Okay, so when I add 8 over here, these 8's cancel, and all I'm left with is 5x. Okay, and then over here, if I do 2 plus 8, I get 10. Okay, so now this says 5 times x equals 10. So here we're multiplying, so I got to do another opposite operation. I want to get this 5 over to the right hand side, and since it's being multiplied, I have to do the opposite of multiplication, which is dividing. Right, so I'm going to divide both sides by 5. Okay, so 5 divided by 5 becomes 1. So essentially those cancel, and what I'm left with is 1x. And then 10 divided by 5 is 2. Right, so now we're done, right? Because x is by itself, we have figured out that x must equal 2, but I want to test it real quick, right? If I were to plug a 2 back into my original equation, right? So remember we had 5x minus 8 equals 2. So I'm going to plug a 2 in and see if it works, right? So this will be 5 times 2 minus 8 equals 2. Well, 5 times 2 is 10. And then 10 minus 8 is 2, right? So we get 2 equals 2. So that makes a true statement. So that's how I know I got the right answer. All right, so we're going to try it again. This time it's a little bit more complicated because we have some more parts going on here, but not a big deal. I'll show you how to handle those. Okay, oops, pen is malfunctioning. And let me get rid of this stuff so it's not in the way. All right, so notice in this one we have x's on both sides. So when I see that situation, I like to get all of my x's on one side of the equation. So I'm going to take this 2x and I'm going to move it over here with the 5x. So since this is a positive 2x, I'm going to subtract 2x, and whatever I do on one side, I have to do on the other. Okay, so the 2x's will cancel. All that's left over here is that negative 6. And then over here, I have to subtract 2x, but I can only subtract a 2x from something else that already has an x in it. So I would have to subtract it from the 5x. So 5x minus 2x is 3x. And then I still have this minus 3 here. Okay, so now what I'm going to do is I'm going to move this negative 3 over to the right hand side. Right, I'm going to start moving stuff away from the x that I'm trying to solve for. So I'm going to add 3. Right, 3's cancel, and we get 3x equals, well, negative 6 plus 3 is negative 3. All right, and then I'm going to extend my line a little bit more. And so now we have 3 times x, so it's kind of like this situation over here. I'm going to have to divide by 3, right, to undo that multiplication. So the 3's cancel, and we get x equals, well, negative 3 divided by 3 is negative 1. So there we go. that would be our solution, right? X is by itself. We have a number on the right-hand side. If I were to take this -1 and plug it in where I see the x's, I would get the same number on both sides. It would make a true statement. All right, last one here. This one has some parentheses in it, so we might run into those from time to time, so I wanted you to see one with the parentheses. So notice this number outside of the parentheses here. When we see this situation, you might remember something called the distributive property, and this is where we're going to take this number on the outside of the parentheses and we're going to multiply everything inside the parentheses by that 2. Okay, so when I do 2 times -5x, I get -10x, and when I do 2 times 3, I get 6. And now the parentheses are gone. So that's how we get rid of it. We use the distributive property to get rid of those parentheses. Now we still have a 26 on the right-hand side. Okay. And then I'm going to do the same thing that I did in the previous 2 problems. I'm going to start moving everything away from the x. I'm going to move everything over to the other side until the x is by itself. So I'm going to subtract 6 first. All right, so those go. And I've got -10x equals, and then 26 minus 6 is 20. And then we'll divide both sides by -10. Okay, so the 10's cancel. And we've got x equals, well, 20 divided by -10 is -2. And there we go. All right, so that's your quick review on solving equations. So let's see how that applies to our function situation. All right, so we've been talking about these functions and how to evaluate a function if we were given an input, but sometimes we're not going to be given the input. Instead, we'll be given the output of a function and be asked to go backwards and figure out what the input was. All right, so let's look at an example of that. So here I have a function. The name is f, the input is x, and the rule is -4x plus 4. All right, and for starters, they're just asking us, well, let's plug a -5 in, right? So this -5 is inside of the parentheses, so this is an input. So to do f of -5, I'm going to take my rule and I'm going to rewrite it where x is replaced with that -5. Right? So instead of an x, I now have a -5. And then we use our order of operations to calculate, right? So -4 times -5 is a positive 20. And then 20 plus 4 is 24. So f of -5 equals 24. Means I put a -5 in, I got a 24 out. All right. Now look at this one. This one's a little bit different. Notice they did not give me the number inside of the parentheses here. It's not there. We don't know what the input is. But they gave us this number over here, this -24. Right? This is the output. So they told us what we're going to get out of the function. Our job is to figure out what goes in. All right, so here's our rule, -4x plus 4. And this 24 is replacing f of x, right? So instead of putting an f of x over here, we're just going to put the number -24, because that is the output. I want to do stuff to something and get a -24 out. Okay, and you're going to notice right away this looks a lot like an equation because our job is to find x. Right? We've got to figure out what value of x is going to produce that -24, and the easy way to do that is to treat it like an equation and solve. So I'm going to start by subtracting 4 on both sides. Okay, so -24 minus 4 is a -28. The 4's cancel, and I get a -4x. So this is multiplication, so I'm going to divide. All right, so the -4's cancel, and we got x all by itself, and then -28 divided by -4 is a positive 7, right? Negative divided by a negative is a positive. 28 divided by 4 is 7. So our input, if I were to take a 7 and plug it in for x, I would get this -24 for an output. Okay. Let's do it one more time. Right, so you notice like when we do get that output situation, it leads to a situation where we're going to be solving an equation, okay? So new function here, right? First one, they give us the input. They give us the number inside the parentheses, so we have the input. So I'm going to say f of 2 equals, and I'm going to say negative 2 times 2 minus 6, right? So the x gets replaced with the input. And then I use my order of operations to calculate. So this will be negative 4 minus 6. There we go. And then negative 4 minus 6 is negative 10. All right, so we would say f of 2 equals negative 10. I put a 2 in, I got a negative 10 out. Now when I look at this one, they did not give me the input. Instead, they gave me the output. Okay, so I'm going to say 20 has to equal negative 2x minus 6. I don't know what x is, but I do know that I have to get a 20 out. So this creates that equation situation, which is why we reviewed the equations. And we've got to solve for x. So I'm going to start by adding 6 to both sides. So we've got 26. And the 6's cancel, so we have a negative 2x left over on the right-hand side. Now to separate the negative 2 and the x, we're going to have to divide because they're being multiplied. So the negative 2's cancel. We get x, and 26 divided by negative 2 is negative 13. And there we go. So when I put a negative 13 into this function, I'm going to get my 20 out. Okay? All right, guys. That's it for today. Make sure you get those practice problems done. All right. Have a great day, guys.